is the next question? I don't even know.
The story of Galileo.
Okay.
The special word.
The story of Galileo, that is on the first video. I told that, and I said there were 4 different approaches. Again, I will show you and humiliate you on the internet if you're giggling. And I won't say your name, Mendor Callow, but yeah, we're broke. So, so after the Galileo question, what's the next question then? Okay, so scientific anti-realism. So what does it say about that?
It says give historical examples / arguments that support it. Some key words are optical, ether, the 8th, and geocentrism, phlogiston, Kraut's hydrogen hypothesis.
Okay. So this is, I'm basically going to be saying stuff that's straight from the anti-realism sheet that's front and back, and that was the fill in the blank, or there was just a few blanks that you had to fill in. So anti-realism. First off, anti-realism, a lot of you have mistaken, and just not necessarily this class, but over my 5 classes, a lot of people think that anti-realists don't value science. And some people are like, what would they think about, what would an anti-realist think about Emily du Châtelet? That she's wasting her time or something. No, no, no. So an anti-realist can be deadly serious about science and appreciate it and think it's one of the greatest inventions in history. But an anti-realist simply says that science doesn't give us a true, accurate description of the way the world really is. Scientific anti-realism says, in the same way that the library catalog system doesn't give us the true way of organizing books, science just gives us one of many ways, and it works, right? It works. So the classic example, and the reason why we looked at scientific anti-realism, what from this unit that we started with is the main example of scientific anti-realism? Starts with a G and ends with eocentrism.
Geocentrism.
Bingo. So geocentrism, don't you remember, it totally worked. It totally made predictions. It was accepted for whatever, 1,000 years and more. And it turns out to be false, right? So the anti-realist is like, why would we think that any of these theories actually get us the truth? And so they give us, well, whatever, I just consolidated these different arguments from different sources. So argument number 1, and I'm going off, like, I don't have it in front of me, but this is basically, I'm trying to summarize the notes you already had. So argument number 1 is basically that you can have scientific theories that predict things, that work, that are testable, and that are accepted. And for hundreds of years this happens, and then they turn out to be false. Example number 1 is geocentrism, right? Example number 2, I'm trying to remember what, is this optical ether theory thing. And what is important to know about the optical ether theory is basically this. Some dude, I think his name's Fresnel, Fresnel has a theory based on this entity called optical ether. And he says, if my theory is correct, and he predicts this result, a bright spot in this kind of circular whatever object, and runs the experiment, and poof, it appears. The bright spot appears like magic, like just like he said. And guess what? We don't think there's any such thing as ether anymore, right? So he made this prediction and it totally worked, and we don't think there's any such thing as ether. Ether, you don't have to know this, but ether was, in the same way that everybody knows that sound has to travel through a medium, right? So sound, why are there no explosions in space? Because there's no air, sound has to travel through a medium. I don't know what you just said. And the reason why bank robbers or whatever in the train robbers put their heads down on the train tracks because sound travels faster through that metal, the steel, or iron or whatever. I don't know exactly what train tracks are made of, than through the air. And so sound has to travel through something. Scientists for a couple of centuries thought, well, sound has to travel through something. Light has to travel through something too. And what does light have to travel through? Let's say there must be something called ether, right, in space, because clearly light is traveling through space. That's what ether is. And we don't think it exists anymore. Basically, right now, you should know, right, or I guess you shouldn't know this for history, but physics, light doesn't need a medium, right? Light can travel through empty space. Yeah.
Do anti-realists think we'll ever find like the true meaning?
No. Good. So the question, do anti-realists think that we'll ever find the true meaning? No, because that's not science. That's not what science does. I'm trying to think of an analogy. Science isn't that kind of tool. And so I'm trying to think of some tool that, like, I don't know. So let's say a hammer, and so hammers are good for hammering nails. And you say, do people who hammer ever think that there'll be a hammer that can put a car together? And you'd be like, no, that's not what hammers do. Hammers don't put cars together. Science doesn't find the truth. Like, it's just not that kind of thing. That's nothing against science. It totally helps us make progress and do all these things, but it's not the way reality is. Argument or example number 2 about successful theories. Fresnel and optical ether, geocentrism, and then phlogiston, which is a fun one. Scientists I can't remember the dates now, it's on your handout, but before Lavoisier kind of discovers oxygen, scientists thought there was a theoretical entity. They thought that the way things burned was because they had phlogiston in them. So a candle burns. Why does it burn? What's inside it? Phlogiston. And when the candle stops burning, what does it run out of? Phlogiston. And that is very different because that's inside versus the idea that oxygen, we need oxygen outside. That's a gas for combustion. And that worked, and that explained all sorts of things for a while. And now we don't think there's ever anything such as, there never was anything such as phlogiston, right? But it worked. So it wasn't real, but it totally worked. Example number 3 is, or whatever, 4 is Isaac Newton and light and the wave particle duality of light. And that's not as huge of a deal because it's a little bit confusing. But basically, scientists currently say, you can look in any physics textbook, that a light acts as a particle and it acts as a wave. And if you know physics, you know that that's like saying light acts like a square and it acts like a circle. Those are 2 radically contradictory concepts. So how can light act like a square and a circle? How can light act as a wave and a particle? It's contradictory. So people are like, well, maybe it just works. It's not what light really is, a wave or a particle. And it's true. Like, it's weird. You can do experiments that treat light as a wave and it acts as a wave. And you can do experiments that treat light as if it's a particle and that'll act like a particle, but those things are totally contradictory. Yeah.
Do you think, okay, this is kind of out there, but like, so light is both waves and particles.
Yeah, they say it.
And that can't be.
Definitely not at the same time.
Yeah, but and then they said, and then it's in the Bible. It says God is light, and God created Jesus, who's 100% man, 100% God, and so the light is like showing that it's like a wave, and it's like a particle, and it's like a circle and a square. 100% God, 100% man.
So yeah, that's super interesting. So the idea is like, in the same way that there's clearly a being that was fully God and fully human, which seem to be contradictory things, right? How could someone be fully God and fully human? Maybe that's the way light is. So in that sense, you'd be making a fancy religious argument for scientific realism, right? That light is both a particle and a wave. There's one thing I would say is I don't know that the Bible is saying God is part of the God is part of the electromagnetic spectrum, right? It's more of the metaphor. I would think in terms of poetry, God is light in terms of the images and the, no darkness in. But there are really difficult issues about how can something be both God and both man, right? And that's a question in philosophy of religion that is too. I actually have a couple books over there that I could show you if you want. But yeah, that's a. It's always been hard. What does that even mean, that Jesus is somehow both fully God and fully human? So far we've only had one argument for scientific anti-realism. Namely, you can have all sorts of successful theories that work and predict things, and then they turn out to be false. Argument number 2 for anti-realism is sometimes you can have theories that are viewed to be false, and you test them and they fail the test. And there's other explanations for it, and they're just viewed as wrong. And then 100 years later, you're like, oops, I guess that was right. And the example is a guy named Prout, I don't even know, it's probably Prout, his hydrogen hypothesis, that hydrogen is the building block of matter. He hypothesized this, people test it, people try to prove it, and it fails. And they're like, oh, it's wrong. And then 100 years later or 200 years later, they're like, oh, and that's what we are currently taught in chemistry, that hydrogen is the basic building block of matter. So sometimes there's theories that are true, and they don't work, and they fail tests, and they don't make predictions. Point number 3, and I think this is super kind of persuasive. Point number 3, and this is the average American family thing. Your favorite. Theoretical entities. Wait, how does it say? Yes. Theoretical entities can be useful without being real. So the average American family, when you walk around Colorado and you walk around Denver and you knock on people's houses and you're like, where's the average American family? I really want to meet him. It's not quite like in Elf, the world's greatest cup of coffee, and he walks in. He's like, you did it! The world's greatest cup of coffee! It's maybe you could find that, but you sure can't find the average American family with 2.4 children. But everybody knows how that concept works, right? You know what they're getting at, and even though there's no 2.4 children, you know that like what that means as an average. So maybe science is like that. What are some examples of theoretical entities in science? How about one from the video you watched last week? How quickly one forgets. Starts with an E and ends with energy. Right? Energy. It does actually. Energy. Energy. Give me some more. The force. Yes, any force. Give me gravity. Black holes. What? Electrons, quarks, superstrings, anything that you can't, that's unobservable, right? That you can't see. Black holes, dark energy, dark matter, electrons, gravity, all that, energy. So the question that you can ask your science teacher is, how do we know that electrons aren't just like the average American family, right? It works, but why should we think they're actually real? The average American family totally works to explain things, but it's not actually real. So continuing on with anti-realism, there is then this syllogism, and it's on the board for those of you watching, right? How do I point at it? Right there. And it's totally backwards on the video. If P then Q, Q therefore P, and notice what this says on the study guide. I've added a few, like actually a historical example. What is it? Einstein, Eddington, the solar eclipse of 1919. So here's how it goes. Einstein has his theory of general relativity. You don't like, all you really need to know, Einstein has a theory that makes a prediction. And the only way to test that prediction is during a solar eclipse of 1919. So in 1919, one of the more famous scientists in the world at that time, a guy named Arthur Eddington, goes into, I think, the Pacific, probably like somewhere in the middle of nowhere where you can totally catch the full eclipse. And you don't have to know the details, but it was ultimately about like you'd be able to see stars that are actually behind the sun, which is unusual because you can't see them straight on, but because the light would be bent by gravity, they would be viewable now. And so basically Einstein makes a prediction. Einstein's theory makes a prediction. So if Einstein's theory is right, we will see such and such result in the solar eclipse. If Einstein's theory is right, we will see a result in the, this result in the eclipse. That's Q. Q happens. They detect that result. Q. We saw Einstein's result in the solar eclipse. Therefore, P. Therefore, Einstein is right. Not necessarily. And there's all sorts of examples of if P then Q not being true, right? If you are typing, then let's be pessimistic. No, let's not. If you are typing, then your hands are sore. Q, your hands are sore. Therefore, you're typing? Maybe not necessarily, right? So this is, some people on the quiz, they're like, this is invalid. That's the point. This is fallacious. This is bad reasoning, right? If my theory is correct, this will happen. This happened, therefore my theory is correct? Nope, not necessarily. It might be, but might not be. But that's not how it worked in the history of science with Einstein's theory. The press blows up and they're like, Einstein was right, he's God, oh my gosh. And that's fallacious, that's wrong. So that's just an interesting example. Einstein also said, he was like, even if that doesn't happen, I know my theory is still right because it's true no matter what. So that is anti-realism. What's the next question, Annabelle?
The identified 3 to 4 consequences results in technology.
Okay, so technology. Now we're getting more, to the recent stuff. Technology in the printing press. So, trying to think how many consequences were on that DBQ. The first consequence on the DBQ was that the printing press caused a lot of religious strife, a lot of religious discord. It destroyed peace because the Pope is saying nasty things about Luther, and Luther is saying nasty things, namely things like, hey, let's wash our hands in their blood, right? And this is spreading all over Germany, and people are reading this, and they're being incited and inflamed. And so that causes a lot of, doesn't make people necessarily friends with each other, Lutherans and Catholics. That was the first one. The second example on the DBQ, I think, was the map where in 1500, all of Europe is Catholic. And then like 60 years later, right around the time after the printing press, Protestantism emerges, and now Europe is totally divided, Protestant, Catholic. It totally changes the makeup of Europe. Yeah.
Is that because like the printing press has its own agenda?
The printing press have its own agenda. Technologies have consequences that usually the inventors really have no idea about. I would just say because all these ideas are spreading, right? Luther, there was another document that said 1/3 of everything that was published in Germany for 7 years was from Luther. So Luther's ideas are going out everywhere. People are reading them and like, what? Catholics? We don't like you anymore. So Protestant Reformation spreads. The next document was document 6, which was about Columbus's letter. And Columbus's letter, the important thing is that he says, hey, I discovered these islands and I claimed them for us. And so that letter, which announces the discovery of the New World, doesn't just stay with the King of Spain. Within a year, as a lot of you pointed out in the DBQ, within a year, it races through all of Europe. And all of Europe all of a sudden knows, whoa, I want to get me some of those islands. Like the explorations of discovery launch, and all sorts of, like, some group of dudes called the Pilgrims, right, start sailing. That's, you could say that that's from the printing press. Next one I think is, like, there's 3 maps and they become progressively more accurate over the span of something like 80 years. And so our knowledge of the world expands as a result of the printing press, because all these news of travels and voyages are going around the world. And so people can, it's almost like Wikipedia. You can, like, oh, like, different people can contribute to the knowledge of the world. Document 8 was the fact that that books that had 2,000 years old, Plato and Aristotle and Augustine and Aquinas and whatever, now I'm drawing a blank, Homer, and all these hugely important documents that some of you wrote, they're just for entertainment. It's not just for entertainment. Like, a lot of these people, like, here's how I can live, here's how to really think about the world truly. These are suddenly available, mass produced. This is the first time in history that they can be printed. Otherwise, they had to be copied hand by hand. And then the next document says the writings that were written right away don't even have to be copied hand by hand. That boom, they're just printed, and everybody knows instantly, here's what all these people are thinking. Those are the kind of social, historical consequences of the printing press. Then we got into, like, just general results of technology. And there were 4. And one of them has to do with TV and smoke signals. And what's the idea about technology that was described by TV and smoke signals? Yeah, smoke signals are not the form of smoke signals. The structure, the design of smoke signals excludes deep conversation. And the claim that Neil Postman made is also that the form or the structure or the design of television excludes deep conversation, because television is designed for visual imagery and images. It's not designed for discussion. And so he famously says that the television made it impossible for a 300-pound person to be elected president, because we're so visual now. That's one one kind of consequence in our minds of how technologies work on our minds. What was this? I think the second one was maybe, which one was it? Which one? The clock. What is the principle about the clock?
That, like, it affects how we think about our lives day to day and how we function.
So technologies will shape how we think, what we see, how we experience the world. And what did not exist before clocks? The seconds and minutes. The clock invents, and some people could say no, it discovers, but, like, invents seconds and minutes. It invents the idea of moment by moment. And that is a radically different experience that people didn't have before the 1400s. Yeah.
Then they can also say you became slaves of time.
Yeah, and so it talks about we were time, what does he say? Time keepers, then time savers, then time servers. And now we have the clock, and everybody, like, wow, isn't it so great? And everybody says, I never have enough time, right? The last technology that has kind of an idea behind it was eyeglasses. And what's the idea that's embedded? So the principle was that technologies have ideas embedded in them that go beyond the function of the technology. The person who invented eyeglasses probably didn't realize that the premise was anatomy doesn't have to be destiny. You can change your eyes, and why not? You can change your DNA. It seems like there was a Super Bowl commercial that made me think of that yesterday, and I can't remember what it was. I don't know. I can't remember. But I remember thinking, like, that's totally like it's from the eyeglasses. So those are your, like, that's the stuff on printing press and technologies. What's the next? We've got to be coming to the end pretty soon here. What's the next study go? Probably like Newton and Einstein and all that. So clockwork universe. The clockwork universe has 3 parts: quantification, mechanization, disenchantment. What the clockwork universe is the idea that the universe runs like a clock, a brilliantly designed clock, a perfectly functioning clock that God wound up and just lets it run on its own. It's called deism. And as a result, you might remember, like, there's no miracles because God started it, and God's too good of a designer to have to intervene. So why would God go back and be like, oops, I need to fix something and like mess with nature? So there's no miracles. So Thomas Jefferson cuts out in his New Testament all the miracles out of his Bible. He's like, that didn't happen. So the clockwork universe, part of it is quantification. What does that mean? What's a word you could summarize that with? Just the letter N. It's definitely math. Number, right? Numbers. So Newton's theory of gravity has all like this mass and that mass, and you square the distance, and you have like all these numbers. And then Aristotle's theory of gravity is not quantifiable.
Like the math is the language.
So quantification is that mathematics is the language of nature. Galileo says this. Copernicus says this. Copernicus says, if you don't accept my theory and you don't know any math, I don't really care. Like, you want to understand the world, understand math. And so that's different from Aristotle's view of gravity, which is like, why do things fall? Because they have a final purpose that makes them go down or whatever. Super qualitative. Yeah. So mechanization is the second part of the clockwork universe. Mathematics and quantification. Then mechanization is everything's a machine. And everything runs like a machine. And everything's subject to the laws of nature. And do the laws of nature change? It starts with an N and ends with an O. The laws of nature don't change. And this is where Laplace said, if you knew the position of every object and every force acting on it, you would know how it would run for the rest of eternity. And you would know how it ran for all of the past. It is totally determined. There's no freedom. There's no free will. Science says, like, the laws of physics cause everything. You're made of atoms. You're a machine. Animals are machines. This is a big fancy machine. There's no soul or spirit. And it all is subject to the laws of nature. And the laws of nature can't be changed. It's the way they have to be. That is mechanization. What is determinism again? What does it mean that everything is determined? Everything's planned. The opposite would be free will. So determinism means there's no free will. Everything must happen the way it's going to happen. Yeah, like you can calculate, like if you're subject to gravity, you don't have any free will, right? You're like, oh, I think I'll slow down now. Like, no, you can't. Like, you are subject to the law of gravity. There's no free will there. We can calculate exactly when you will land, right? We can calculate exactly where the astronauts will land in the water, and that's why they have ships that go rescue them, right, when they land in the ocean after their missions, because physics tells us if they're going this speed at that, angle, this is exactly where they're going to land. It's totally determined. What were we talking about? What is this? Mechanism and clockwork universe. Last one is disenchantment. Namely, the world is no longer charged with the grandeur of God. There's no color in the world. It's in our minds. There's no beauty. Like, beauty is just a subjective thing in our minds. The sound, the smells, the taste, that's in our heads. And really, the world out there is colorless. There's no purposes in the world. It's just matter in motion. Cold, hard, purposeless, and subject to whatever we want to do to it. Uncle Andrew says, the guinea pigs were mine. I can do what I want with them. Jadis says the same thing about Charn. She kills all the people of Charn. That was what they were there for. And they even make the connection. That's what Uncle Andrew said about the guinea pigs. That's a disenchanted world. It's not sacred. If the world is sacred, you might like hesitate to like chop down the trees. That's a little bit of like the whole Lorax story, right? He's like the spirit of the trees, right? He speaks for the trees. And totally in Lord of the Rings, the Ents that have like, there's this kind of whatever the Ents are, right? That's like a spirit in the trees. And when they become disenchanted, they're just regular trees, right? C.S. Lewis and Tolkien, they're both, I just read a book the other day about like their vision. They're totally environmentalists. Like they're totally environmentalists in a good way. So that is mechanization, all that stuff, disenchantment. What's the next one? Different theories of gravity. Where are we on time? Yeah, we'll pull this off. So there's Aristotelian gravity, Einsteinian gravity, Newtonian gravity. Aristotle's view of gravity. He wouldn't have even said the word gravity, right? But why does Aristotle think things fall? They want to. There's an active principle in them. There's a soul or a spirit in them. Another fancy word might be a telos, a final cause in them that wants to get back to the center or to the earth. Why does fire rise? Because the heavens are fiery, thought the medievals, and the fire rises because it wants to get back to, there's something inside of fire that wants to get back to the heavens. Super non-numbers, right? No quantitative stuff at all. It's all qualitative. That's Aristotle's view. Why does Newton say things fall? The short answer is what? Gravity, right? And his says that there's two objects that attract each other. And you don't have to know the equation, but it's like you multiply one mass times another mass divided by the square of the distance. And so you can calculate the force. Gravity is a force that reaches out. And do you remember how fast does he hypothesize that it reaches out? Instantaneously, right? He's like, gravity is instantly acting on everything in the everything. You have gravity right now, right? Like we could calculate the force of your attraction, some girl across the room to some guy across the room. We could calculate the force of their attraction. There's lots of other forces. The biggest thing that's on you guys right now is the earth, right? Pulling on you. So that's Newton's view of gravity. And to distinguish that, Einstein, and it's kind of fancy why he has a problem with Newton. But what does Einstein realize that Newton's theory of gravity implies about speed? That it's instantaneous. But the sun, in terms of light, how long does it take light to get to us? 8 minutes from the sun. And so if the sun is causing gravity and light to come to us, how could gravity travel faster than the speed of light? So Einstein changes the view of gravity. And that view, in one word, it starts with a C, curved. Space and time are curved. You could also use a word that starts with a W. No, whoop. No, warp. Warped. So it's warping space and time. So it's curved. And what's the example of a trampoline have to do with any of that? So it's like a bowling ball and a trampoline, and it's totally curved. And so is there a force that's reaching out to grab the moon? Why is the moon going around the earth? Because it's on that curvature, and it's just, it's moving through the fabric of space-time, which is weird, but just think of a bowling ball and a trampoline, and like a marble going around that bowling ball. It's not because the the bowling ball is reaching out and grabbing it invisibly with the force called gravity. It's because it's shaping the space itself, which is weird. Next one is what? That's the theories of gravity. What's Annabelle? How to launch a satellite in orbit and what? Newton, Apple, weightlessness. And then what's the next one? Is it about universal? And is that the last one? Du Châtelet? Because I think I erased, like did I put Du Châtelet on there?
Yes.
Don't worry about Du Châtelet. I won't put that on the test.
Was that the thing that
Yeah.
So everybody explain the story.
You don't have to do, I won't have Du Châtelet on there.
And what about explain how to launch a satellite?
Yeah, so I want you to, so now this will be the last one, and we're going to tie, I think I want to start with the last bullet point, which is, I think, probably something about universal gravitation. So it should be, last point at the bottom of your the study guide, I think. And so the story of Isaac Newton and why Isaac Newton is the culmination of the scientific revolution. It involves an apple, and it's not just an apple. The apple hits him on the head, and then what is the further extension of that? He looks and sees the moon. And why is that a big deal? Same force, and so he unifies. Hawk. So gravity, the same force, namely gravity, is acting on the apple, and it's acting on the moon, and the apple is falling, and the moon is also falling. And so why is this universal? There was the distinction between below the moon and above the moon, and below the moon had its own set of laws, and it was imperfect, and above the moon had a different set of laws, and it was perfect in perfect circles. And gravity, according to Newton, doesn't follow the certain laws of the below or the above. He unifies heaven and earth. He unifies the celestial and the terrestrial. The apple and the moon and Saturn and Neptune and everything universal is under the influence of gravity. And because of that, the moon is falling. And so this is where like the weightlessness stuff happens. He talks about how you launch a satellite. And what does that have to do with throwing a baseball? If you're at the top of a tower or something and you throw a baseball kind of hard, what will happen to it? It'll go straight for a while, then it will fall and land. Why does it land? Gravity. If you throw that ball a little bit harder, it'll go farther, and then it will land again. Why does it land again? Gravity. If you throw it super duper hard, it will fall, and it will keep falling, and it will keep falling, and it will keep falling. And that's if you launch it, you don't have to know this number, but 8,000 meters a second, that's how you launch satellites into orbit. They're falling around the Earth, just like the moon is. But the question is, why are they falling? Due to what letter of the alphabet? G? Whatever. Due to gravity, right? Why is it falling? It's due to gravity. And so related to this, to show that this is all about gravity, this is why we did weightlessness and talked about weightlessness. And so the question I initially asked was, when astronauts are floating in space, why are they floating? And what's the answer that most people give? Because there's no gravity. Or they say, but I don't know the number, but it's like maybe 99, probably like I would bet is 95% less. You could Google it. Like what's the way you would Google it is what's the value of G at the space station? because the value of G on planet Earth is 9.8 meters per second. So somebody, if you want, Google it and like, what's the value of G on the at the space station or something? Yeah.
Does Mars, like other planets, have their own gravity?
Yeah, every object has its own gravity. Say.
Like, let's compare it to on the International Space Station at 4,000 gravitational strength compared to the surface of Earth.
89%? Okay, 90%. I was thinking it was Mars, but 90% is still a lot of, like, it's not, you're like, it's still 90% gravity. Oh, that's why they're floating. No. Yeah. So the value of G, I don't know what 90% of 9.8 is, but whatever. So floating. So the analogy to emphasize that they're not floating due to no gravity, but because it's total gravity, is the Tower of Doom. And you go up to the top of the Tower of Doom, and right when they release you, what do you have in your hand that you let go? A quarter. And as it drops, what would you see? You would see a quarter. You would. It would look like it was floating right in front of you. And if you fell for, a minute, it would totally be floating, especially if it was enclosed and there was no air resistance all around you. And so it would look like it's floating. And the question I asked, why are you falling? What force? Gravity. Why is the quarter falling? Gravity. But notice, it looks like it's floating. Why do the astronauts look like they're floating? Because they're falling around the Earth. Just like what object is falling around the Earth? The moon. And just like what object is falling that hit Newton on the head? The apple, right? So that's the tie-in for all that stuff. And maybe that's all, yeah? Any last-minute questions before we say goodbye to the internet? Say goodbye, internet.
Bye, Internet.
Bye. This is totally going to go viral. And you guys are going to be famous, and they're going to put ads on my wall. Bye-bye.